Let's look at this picture. Everything that I need to say for my given is going to be line 1, line 2, and then that line 1 is perpendicular to line 4. That's what this symbol means. And here's my line 4. So line 1 is perpendicular to line 4. And line 2 is perpendicular to line 4. Now, we know that theorem 2.9 tells us if two lines are perpendicular to the same line, then they're parallel. So what I would have to do here is come back as I'm reviewing this and say, I never showed that line 1 is parallel to line 2. Now I'm showing line 1 and line 2 are parallel. And because I have two lines that are parallel and a transversal in line 4, and I don't have to label line 4 as a transversal, I just want to talk about it here today. Since they're both perpendicular to the same line, they have to be parallel to each other, and then we can now go on to say that we can solve for angles 1, 2, 3, or 4, depending on what it's asking us to do. So let's scroll down and see what we're asked to do. Here I say I'm going to prove the same side interior angles. And what I want you guys to do is look up here at your chart. And now, what I'm going to ask you guys to do in the chat is tell me, would you rather see same side interior angles as a 2-column or a paragraph proof? 2-column, that's what I was going to suggest. Perfect. So let me clear this check mark off and let's get back down to it. So I'm going to go ahead and grab a screenshot of this. Move it over here for when we actually need it. And now let's scroll down. Here's my written paragraph proof. You can see this one's a bit longer. But here's my 2-column proof. And now I need to come back here. And look, I made a prediction about these needing to be marked parallel to do this proof. And that prediction was actually wrong. The way I proved it didn't require those to be parallel, which is interesting, right? And I see why. I didn't have to draw it because I'm making that statement right here in my third hypothesis. Let's see. We only really need this part of the picture. Will it fit? It's going to be a rough one. All right, we're just going to have to bounce them back. And we'll do this. Okay. So here, if I look at my 2-column proof, I wrote line 1 is perpendicular to line 4. If I come back over here, let me get my annotation tool up. That's absolutely true. I wrote in my picture line 4 and line 1 are perpendicular, so that's true. I also wrote that line 2 is perpendicular to line 4. Here's line 4, and they're perpendicular. So both of those statements are true. So I can say line 1 is perpendicular to line 4, and line 2 is perpendicular to line 4 because they were given. Does everyone see how I made them the given? I addressed that I have line 1, 2, and 4, and I've shown they're perpendicular to each other. So I am allowed to say that's given. Now, because I already have this perpendicular symbol here, and we know perpendicular angles are 90 degrees, I know angle 1 is also 90 degrees, and that's given. Here's where I said I needed to show that line 1 and line 2 are parallel, but I didn't because in my proof, I'm saying my third hypothesis is that line 1 is parallel to line 2 because of theorem 2.9. And theorem 2.9, if we look it up, says two lines are parallel if they are perpendicular to the same line. And I can see for sure those two lines would have to be parallel because they're perpendicular to the same line. One great thing about writing proofs is the only proof you can't use or assume to be true is the proof that you're proving. So we don't have to do any work on theorem 2.9. We know it's true already, so we can use it freely. That's like, if I ask you what is a cat, you could use the word mammal because a mammal is already established and we assume that our reader knows what a mammal is. We already know what theorem 2.9 is, and we are able to do that. Next, since I know what angle 1 is, I'm always going to base my first real math step off of angle 1. And if I come over here, I can see that angle 1 and angle 2 are in fact linear pairs. So I would say angle 1 plus angle 2 is equal to 180 degrees. What theorem tells me I'm allowed to say that angle 1 plus angle 2 is 180 degrees? I just tell you which theorem that is right there. Again, you're going to see that here I have angle 1 plus angle 2 is equal to 180, but I already know angle 1 is 90. So I've subtracted 90 from both sides, and I'm left with angle 2 is equal to 90 by the subtraction property of equality. So basically all you're doing here is saying, I did this because of this. I did this because of this. I did this because of this. I could do this because of this. I could do this because of this. Personally, I find these so much easier, more efficient, and I find that I do a much better job writing a written paragraph proof if I can base it off of this. Here, I have the alternate interior angles. So all I want to make sure when I look at my picture is that angle 2 and angle 3 are in fact alternate interior. Well, they're inside my parallel lines and they're on opposite sides of the transversal. These are definitely alternate interior angles. And the alternate interior angles tells us that alternate theorem tells us that alternate interior angles are congruent. So that would basically tell me 2 is congruent to 3 and 1 is congruent to 4. But only one of those statements right now is relevant to our proof because I already know what angle 2 is. So I can say that if angle 2 is something, then angle 3 is something. And now I also know that angle 3 is 90 degrees by the alternate interior angles theorem. So my next step is, you see how every time I write one of these, the second part, the new part, ends up in my next piece? And this is what I meant by a nice little bit of flow. Every time I write these, and the way I organize them is that the one on the right is my new piece, and I'm finding something out about it. So I put it down on the left, and then I find something out about the one on the right, put it down, and now I know that's 90 degrees. And look right here, angle 2 plus angle 4. And just double check, did I verify that angle 2 is 90 degrees? That's right here in hypothesis 5. And angle 4 was in hypothesis 7, so I can say that 90 plus 90 equals 180. Therefore, angle 2 plus angle 4 is 180 degrees, and that is the definition of supplementary angles. Notice I said I was proving same-side interior angles. Did I ever use that word, though, in my proof? For the 2 column, absolutely not. I would just say I'm proving the same-side interior angles are supplementary, and that's it. I'm done. This is the definition of supplementary. Our reader would know that angle 2 and 4 over here are same side interior. They're on the same side of the transversal, and they're inside the parallel lines. Does that make sense, guys? Is that one a little easier to see?
Yeah, I kind of understand it more.
So what I want to show you is, if you guys feel a little bit better about that, I want to take this proof and show you that it is just this proof with more words, right? And this is why I'm saying, if I were you, I would start every proof with a 2 column. I would do 9 2-column proofs. I would just turn 3 of those into paragraph proofs. Whichever one ends up having the fewest number of subscripts, and what I mean by subscripts here is this one took 8 steps to get where we wanted to go. Our vertical angles, I think, was only 4 or 5, so I would automatically turn the vertical angles into my paragraph proof. But coming back here, let's just do a double check analysis. All right, line 1 is perpendicular to line 4, and line 2 is perpendicular to line 4. We assume is our given part here, and that's exactly that. I've also said that angle 1 is 90 degrees, and I've shown that. And we will show that angles 2 and 4 are supplementary. Isn't that exactly what I showed here? So again, Varun was asking about P and Q. Well, this would be my P because it's in the picture. This would be my P because it's in the picture. And this is my Q because it is what I defined as my end goal, which is right here. Same side interior angles are supplementary. And now I've laid all of that out exactly as it is. And the way we're going to do this is by direct proof. Always direct proof. I'm going to change colors just to show you that I'm no longer working on my assumptions and my conclusions. Here I put line 1 is parallel to line 2. And what I did here is Theorem 2.9 states if two lines are perpendicular to the same line, then they are parallel. In a paragraph proof, you have to actually tell me what the theorems say. You are assuming that your reader is taking the more robust layout of this style of proof in a paragraph proof because they want to see specific details. Now, Theorem 2.9 states if two lines are perpendicular to the same line, then they are parallel. You don't have to draw a picture. You don't have to do anything of that. If your reader wants to investigate that further, they have their notes. They have my website. They can pull up to Theorem 2.9 and make sure it matches your picture. This is more than enough to tell them. And then I'm basically said this is what it states. And since it states that, or since I'm given this, we see that these two lines are parallel. That's all of that in purple is just Theorem 2.9 and what we said. It is 12.13, yes. Now, Jasmine, for knowing that answer, send me a message on Edsby saying you get a +5 on any, either you get a homework pass or a +5 on any test of your choice. Thank you. And I will honor that as soon as this meeting's over. But right now, in purple, do you see how much more space I needed to write that on my left-hand side here, my paragraph proof, versus my 2-column proof? This is why I like the efficiency. I did it in 1, 2, 3, 4, 5 words versus, 3 lines, 4 lines. Now, I'm going to change colors again just so we can see how each one of these matches up. Next, I said angle 1 plus angle 2 is 180. That's this one. And then all of this to show that. And you can see here, all that I'm not highlighting is just the extra info that tells us stuff like the linear pairs theorem says the sum of angle 1 and 2 must be 180, and it was given that angle 1 is 90, and by substitution we can find angle 2. All of that is said exactly the same way right here in hypothesis 5. All right. Next up, I have my alternate interior angles. Go orange on that guy. But look what I had to do here. It takes up so much more space to do a paragraph proof than it does to do anything else. I mean, well, the only other thing else is the 2-column proof. I'm going to have to erase this so we can scroll down. And now we're finally at the last 2 steps, which is taking all of that space. And be careful, make sure you have this on your paper at the end. That's how I know. That is how you get 100%. If you've done everything else right and you miss that, you're going to get a 90% for that one. 10% of your grade is telling me that you have finished writing that proof.